Polymorphism is the capability of a method to do different things based on the object that it is acting upon. Polymorphism is derived from two Greek words, poly and morphs. The word poly means many and morphs means forms. So polymorphism means many forms. It is a feature that allows one method to be used for a general set of actions. Consider a stack, which is a last in first out list. You might have a program that requires three types of stacks. One stack is used for integer values, one for floating point values, and one for characters. The algorithm that implements each stack is the same, even though the data being stored differs. In a non-object oriented language, you would be required to create three different sets of stack functions, with each set using different names. Because of polymorphism, you can specify a general set of stack methods that all share the same names. This means that it is possible to design a generic interface to a group of related activities. This helps reduce complexity by allowing the same interface to be used to specify a general set of action. You, the programmer, do not need to make this selection manually. You need only remember and utilize the general interface. Consider the following example of polymorphism. Suppose we create a program that simulates the movement of several types of animals. Classes fish, frog, and bird represent the three types of animals. Imagine that each of these classes extends superclass animal, which contains a method move and maintains an animal's current location as xy coordinates. Each subclass implements method move. Our program maintains an array of references to objects of the various animal subclasses. To simulate the animal's movements, the program sends each object the same message once per second, namely move. However, each specific type of animal responds to a move message in a unique way. A fish might swim 3 feet, a frog might jump 5 feet, and a bird might fly 10 feet. The program issues the same message, that is move, to each animal object generically, but each object knows how to modify its xy coordinates appropriately for its specific type of movement. Relying on each object to know how to do the right thing, that is, do what is appropriate for that type of object in response to the same method call, is the key concept of polymorphism. The same message, in this case move, sent to a variety of objects has many forms of results, hence the term polymorphism. Polymorphism enables us to program in the general rather than program in the specific. In particular, polymorphism enables us to write programs that process objects that share the same superclass in a class hierarchy as if they are all objects of the superclass. Polymorphism allows you define one interface or method and have multiple implementations. The specific action is determined by the exact nature of the situation. There are two types of polymorphism in Java: compile time polymorphism and runtime polymorphism. We can perform polymorphism in Java by method overloading and method overriding. If you overload a method in Java, it is the example of compile time polymorphism. Runtime polymorphism or dynamic method dispatch is a process in which a call to an overridden method is resolved at runtime rather than compile time. In this process, an overridden method is called through the reference variable of a superclass. The determination of the method to be called is based on the object being referred to by the reference variable. Let's first understand the upcasting before runtime polymorphism. If the reference variable of parent class refers to the object of child class, it is known as upcasting. Imagine we are creating two classes, bike and splendor. Splendor class extends bike class and overrides its run method. We are calling the run method by the reference variable of parent class. Since it refers to the subclass object and subclass method overrides the parent class method, the subclass method is invoked at runtime. Since method invocation is determined by the JVM, not compiler, it is known as runtime polymorphism.